Hi, and welcome to College Algebra 4.2, Graphs of Rational Functions. So in 4.1, we talked a lot about rational functions and how they work, and we focused a lot on vertical asymptotes, holes, and horizontal asymptotes, which thankfully is kind of what we're going to have to focus on today as well. We also then want to find some extra plots or points to plot, typically using our graphing utility. So looking at this first one, we have 3 over x minus 2. First, we should look, do I have any horizontal asymptotes? Remember, horizontal asymptotes are dictated on the degree, and more specifically comparing the degree of the numerator and the denominator. Well, my numerator doesn't have an x, so it would have a degree of 0, but my denominator has an x with a degree of 1. So because my denominator has a higher degree than my numerator, degree, my default horizontal asymptote is going to be at y equals 0. It's important to say why the default one, because if I had something like, I don't know, plus 2 on the outside, this would cause a horizontal shift up to 2, but for now, we'll just say y equals 0. Next, we should do vertical asymptotes and holes. Holes occur when we, factor and cross off and simplify. Here, I'm never factoring, so I have no simplification. Therefore, I have no holes to cross off. So my holes are non-existent here. But vertical asymptote is whenever, again, I'm dividing by 0. That's the issue. So I can do x minus 2 and set that equal to 0 and solve. And we get x equals 2. Okay. Now we should get some points to graph, so take out our graphing utility. We get, let's see, 3 over x minus 2. If you don't have a graphing utility, remember we can always go into ti84calc.com, hit start ti84, and it pulls up this screen right here, which functions the exact same as the calculator I am using on screen. So 3 over x minus 2 graph, and I get the exact same thing I would if I were to hit graph right here. So looking at it, we can see that vertical asymptote at x equals 2 working out. So we need some extra coordinates. So an easy way is always second graph for the table. And just look for some easy values like -1 looks awesome. 1 -3. And looks like that would be it. So then we get this rough sketch with this branch here. We get 3, 3, and 5, 1. Something like that. Okay. Important to note that you can never, ever, ever cross a vertical asymptote. So because I have this x equals 2, and even in my graph here it says error, I know that I'm going to have values to the left and to the right of it. It effectively splits my graph in two. You can sometimes cross a horizontal asymptote. It doesn't happen very often, but you can, because at the end of the day, a horizontal asymptote just describes my end behavior. Y equals 0. It just says that on the far left and on the far right, my arrows are going to head towards that specific value. And that's actually what's happening going on right here. So let's try another one. We have x over x squared minus x minus 2. First thing I should do is factor this. So what multiplies to -2 adds to -1. That would be -2 and +1. We can check for horizontal asymptote. Again, my degree in the denominator is bigger than the degree in the numerator, so we're going to get y equals 0. And then my vertical asymptote and holes. I factored, but I'm not crossing anything out, so I have no holes. So my vertical asymptotes, I'm just going to set both of those parentheticals equal to 0. So we're going to get x equals 2 and x equals -1. Now here, I can see that my graph has 2 vertical asymptotes. So I'm going to need to graph some points to the left here, in the middle, and to the right. So I'm going to need to break it up into 3 sections, which should happen naturally if I look at my graph. So let's see. Get x squared. Oh, is exactly what I get. So let's get some values here. 0, 0 works. So if you don't really get any nice values here in either direction, so we're just going to do a rough sketch based on the graph. Looks like it would look like this. Something to that effect. Now, if you had time or we really wanted to, we could find some of those pinpoint ones. But for the sake of time and brevity, that's good enough for me right now. On to the next one. We have x squared minus 9 over x squared minus 2x minus 3. So we can factor x plus 3, x minus 3. This turns into x plus 1, x minus 3. So horizontal asymptotes, I should look at the degree. Notice that we have the same degree. So because I have the same degree, we do leading coefficient divide by leading coefficient. So I get y equals 1 over 1, or just y equals 1. Now, when I factored, I should notice I get an x minus 3 and an x minus 3. Because I can effectively cross this off, that is representative of my whole, and I'll hold on to that for a second. So my vertical asymptote is when everything else in the denominator equals 0, so I can do x plus 1 equal to 0 to get x equals -1. Whole, we get x minus 3 equals 0, so x equals 3. Now, on your online homework, your web assign, it describes holes as an xy coordinate. We can agree that my x coordinate is going to be 3, so the question becomes, where do I get this other coordinate? Well, you plug in 3 into your reduced fraction. So in this case, it was my simplified fraction, x plus 3 over x plus 1. So I'm going to plug 3 in for there. So 3 plus 3 over 3 plus 1 gives me 6 over 4, or 3/2. So my whole would be defined as the coordinate 3/3, and I'll show you what I mean when we get to it. Okay. Otherwise, we could be able to graph this. So type in our calculator. We should type our original equation in. So we would get x squared minus 9, x squared minus 2x plus or minus 3. Right? Yep. And graph. Okay. Second table, pick some values. So we get, negative 3, 0. But this would be a different color. Negative 3, 0. And what's that? Negative 2, negative 1. So I get this going on right here. We get 0, 3, and 1, 2. And technically speaking, I can also graph 3 and 3/2, which would be, right around here-ish. And I can graph this. Now, if I look at my table value, negative 1's an error, which makes sense. That's a vertical asymptote. I shouldn't get a value there. But also, 3 is an error, which should also make sense because, again, if I plugged in 3 to my original, I get 0 in the denominator. So what we need to do at this coordinate is actually leave it as an open circle. You could label that as your hole, but if you leave it as an open circle, I'll be able to tell. What this is representing is if I just graphed x plus 3, x plus 1, this is what my graph would look like, except for that spot would be filled in. So it's just representing my previous equation. Thank you for listening, and I hope you have a wonderful day.